All right. Here's a video that I've been wanting to try to do, or at least start one. It's kind of a racy topic. I mean, the headline probably captured a few people. It probably captured the attention of some people who think PEMDAS is, or the total order of operations, is a joke. But what I'm saying here is, PEMDAS really sucks. And I know that's kind of like saying, well, I was visited by a three-headed alien, but hear me out. The reasoning that I think pretty much all these acronyms are not that great as far as memorization tools. At first, I'll just start out by saying, this general concept of the order of operations is something represented by just four steps. You've got grouping symbols in the first step, basically your parentheses or brackets. Then you have uh, exponents, or sometimes called indices or orders or powers in some countries. And then you have three steps involving operation steps of multiplication, division, addition, and subtraction. And a lot of confusion starts when some people make some bad assumptions that multiplication and division don't have equal precedence. Some people will think multiplication comes before division. Some people even think strange things like addition comes before subtraction, whereas it really doesn't matter. Um, but the actual steps again, as in a review: parentheses, exponents, multiplication or division, left to right, addition or subtraction, left to right. Yeah, please evict my dumb Aunt Sally. So, the problem that we have with this acronym PEMDAS and the mnemonic, which some may remember as please excuse my dear Aunt Sally. These are really poor memorization tools because some people memorize the order of six letters in the acronym and they lose the meaning of the order of operations. Parentheses are simple enough. They could be your normal parentheses, they could be brackets, or even those curly Q things. Don't even, curly braces, I think maybe, I don't remember braces. Those are grouping symbols. And a lot of people have assumed that when these parentheses or brackets are missing, then we just solve left to right because the acronym is spelled PEMDAS. It's not spelled MDAS or, EMDAS or MDAS or DOS. Um, you know, it all comes out of that memorization of six letters, and losing the soul of what the whole thing's about. The acronym causes a lot of bad habits because there are many people out there who think that when there aren't any parentheses, you just toss out the order of operations. And I've run into these people by the hundreds, in working out these problems. That's false, but many still have that misunderstanding and they stand by it, They'll say, well, why is it called PEMDAS then? If there's no parentheses, you just don't do it. Um, but I have to think it just never sank in during their education that you must go to the next operation on the list if one is missing. Too many people really have failed to understand the real relationship between addition, subtraction, multiplication, and division. I've got that misspelled there. Put addition in there twice, but I meant division. Another big mistake that people make is assuming that multiplication is always performed before division because of the order it falls in PEMDAS. Again, this is false. Multiplication and division have equal precedence and are solved left to right as they are encountered. Division is multiplication by a reciprocal. So you can think of it like almost the same operation, You can divide 10 by 5, or you can multiply 10 by 1/5, and you're still going to get the same answer of 2. So you can do that either way. Addition and subtraction also have equal precedence, and but they're performed after you've done the multiplication and division. Subtraction is just the addition of a negative number. So they're basically the same operation here again, right? I mean, addition and subtraction, very similar. You just solve them left to right. Honestly, it doesn't matter. Once you get down to the addition and subtraction, that really, you just solve them. Um, the whole relationship between operations is lost on people who memorized the order of 6 letters, but forgot or never paid attention that there are only 4 steps to the order of operations. So, the other thing to remember too is that this whole order of operations convention is not some arbitrary convention that was developed by a bunch of old men in wigs back in the 16th century just to make your life miserable hundreds of years later. And to try to work through this and understand it better, we can take a real simple problem and work it out. We can take, I got 4 times 7 plus 3 times 8 plus 12 times 5 equals. Um, so how do you think you'd solve this expression? There are plenty of people out there who memorize PEMDAS. They memorize those 6 letters. They know the E comes after the P, and the D comes after the M, and they'll tell you that since there is no P anywhere in the problem, you just solve left to right. That's false. There's no exponents either, but we do have multiplication, and we do have addition, and we do have subtraction. So let's take a look. This 4 times 7 plus 3 times 8 plus 12 times 5. Look at it this way. Multiplication is shorthand for addition. Think of a court reporter who's having to type out mathematics problems as quickly as the lawyer is speaking them or the witness on the stand is speaking them. I don't know why that would ever happen, but do you think the reporter wants to type out 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4? Do you think they want to type out all those 4s and 3s and 12s? Or maybe should they type out add 4 7s and add 3 8s and add 5 12s? Or would that reporter rather type 4 times 7 plus 3 times 8 plus 12 times 5? Take a guess. I'll wait. I'll wait. You can leave me your response. Oh, okay. So you think it's easier to use the multiplication. So yeah, it would. It's shorthand for addition. Multiplication is repeated addition. All 3 of those expressions are correct because in 2 of them we just replaced the multiplication with equivalent addition. We turned it into a simple addition problem that anyone should be able to do. So let's take a look at them. Let's take a look at the first example where we got 1, 2, 3, 4, 5, 6, 7 fours. With 7 times 4, 4 times 7. And then we have 1, 2, 3, 4, 5, 6, 7, 8 threes. 8 times 3, 3 times 8, whatever. And then we have our 5 12s. You add those all up, you're going to get 112. And the other way to do it, and instead of having all those fours, you could have 4 7s instead of 7 4s. And you could do the same thing, with 3 8s and maybe we still do the 5 12s again. I don't know. You're going to get 112. I could have wrote out 12 5s if I wanted to and added those instead of 5 12s. You still get 112 in either way you go. And so therefore, if you're doing order of operations properly, you're also going to get 112. Because if you follow the order of operations, you're going to perform the multiplication first, and then you're going to add, right? So 4 times 7 is what? 28. 3 times 8 is 24. Your 12 times 5 is 60. When you add those up, you get 112. And some people already are probably looking at this and saying, oh my gosh, this is, give me a real world example. Where would you ever use this garbage in the real world? I hear that all the time. So let's try that. The other thing to remember is that the expression could be written out to describe purchases that maybe you made at the grocery store or whatever. Maybe you bought food at a restaurant. Doesn't matter. We're just going to use this example of the grocery store, real basic. We could imagine that we bought three different types of items at the store that cost $7, $8, and $5 each. We just bought different quantities of each. So we could imagine that we bought four of the $7 item, we bought three of the $8 item, and we bought 12 of the $5 item. The total amount of money that you spent would be $112, which could be represented by 4 times $7 plus 3 times $8 plus 12 times $5 equals 112. So, let's assume that the order we write, ooh, wow, I misspelled right. I should have wrote WRITE. Wow, I'm really bad today. So yeah, even I make mistakes, guys. So let's assume that the order we WRITE, the expression, is based on the order that the cashier's scanning the items, okay? Let's say they're scanning an item and then they're multiplying it by how many you have, right? Sometimes you see them do that. They'll scan one and go, oh, you got three? Okay, I'll times it by three, or I'll times it by 12. So do you think it matters what order your items get scanned in by the cashier? Well, in some stores today, you might be scanning stuff yourself. That's a whole nother thing. I'm just do math. I don't get into society stuff. So anyhow, um, do you think it matters what order the items get scanned in? Does it change how much we pay? If you scan the can of beans before the package of hot dogs, does that change how much I pay? Really? It doesn't really, does it? Look at what I've got here. I've got three examples where I've taken the multiplication and just switched them around. It's the same multiplication, just done in different orders. You work these all out, you're going to get 112. And if you don't believe it, convert that multiplication to the equivalent addition in each case like we did before. You're going to get 112. So this whole fallacy of I was taught left to right in my day, or back in the 50s, I was taught, to go left to right. I was taught the simple math in the 1960s. You just go left to right. Or some people say, oh, before all the new woke math or all the Common Core math, we solved left to right. You could quickly blow that out of the water when you try that above exercise and you compare your answers. If you're going to solve blindly left to right and you're swapping that multiplication around, your cashier's, in one alternate universe, the cashier's scanning one way, in some adjacent alternate universe, the cashier's scanning everything in a different order. Just imagine a multiverse, okay? Yeah, okay, whatever. You go through this operation, and I think I did this right because it kind of made me sick doing it. But in one example, I came out with like 1,300, and then I swapped the multiplication around, worked this out. I came out with $1,288. Um, and then by putting the 12 times 5 in the front, and the 4 times 7, and the 3 times 8, I think I worked it out to be $1,353. So if you're going to solve this stuff blindly left to right and you start moving the multiplication around, which shouldn't change a thing, you are going to get different answers, right? And, like I said, I ran through that really fast and it literally made me nauseous doing it that way. I think I did those right according to the so-called wrong method. But yeah. So people on the internet telling me that, hey, we solved left to right in the good old days, and it's just simple math left to right. What they're telling me is their teachers taught them to get different answers depending on the order that items are scanned at the checkout. So they're telling me, hey, if the cashier scans the 8 cans of beef before the 3 cans of chili, I'm going to pay more or less than I would have if they scanned the chili before the beef. Really? Really? And so yeah, that's kind of ridiculous. Now, there's a lot of other controversial stuff. You get beyond PEMDAS, and I don't want to spend a whole lot of time on this thing, but what the heck is multiplication by juxtaposition, or what the heck is implied multiplication. And this is something maybe a lot of people haven't heard of. A lot of people who get really more involved in order of operations, mathematics, you start getting into science, education. This is kind of like a hot topic for some people, but to go beyond the standard PEMDAS description, we sometimes run into other standards. You run into some odd puzzles on the internet where they're not using multiplication operators. There's something that some scientists use a lot, or they have used a lot. It's in publications called multiplication by juxtaposition or implied multiplication. That's not really covered at all by PEMDAS. And when you have AB, I'm just using AB as representing two numbers, but it's assumed to mean A times B. So AB is A times B with a multiplication symbol. And there I'm just using the asterisk. Sometimes they use an X or whatever. I've even seen a dot. Um, Implied multiplication or multiplication by juxtaposition is when you're assuming multiplication when two variables are placed next to each other, like in AB. There's no multiplication symbol there. Um, Now, the thing about this is the way that they use that thing is it's considered to have precedence somewhere between the exponents and your normal multiplication and division. And once again, I'll just say PEMDAS does not cover this, and a good deal of the education establishment really don't recognize it. They think it's ridiculous, and it does go against PEMDAS. They're teaching a stricter PEMDAS approach, so they really don't consider that at all. But if the assumption of the precedence for this multiplication by juxtaposition as it's been used, and I'm not saying I didn't invent this, I'm the messenger, so don't shoot me over it. But it's basically, you've got the normal four steps, so this would be like step 2.5, in between exponents and your normal multiplication and division. There's other good videos out there. I'm going to try to get this link in the description. This was just one that I ran into. There's a good video out there that has a lot more detail. It's by another YouTube channel that has a lot better graphics than me. I'm kind of a noob at all this stuff, just using PowerPoint and Bandicam and, using my internal laptop microphone, which I know I get it. It's got crappy audio. I understand that, but this is like a zero budget channel right now. So there's a lot better graphics and a better explanation on that whole thing by somebody who knows a lot more about it than I do. Um, um, and so I'll try to put that link in the notes. But multiplication by juxtaposition is often discounted by educators who teach the more strict PEMDAS approach. So I'm not really going to get into that debate anymore. I'm just simply going to say that there's other good information out there that explains both sides of it. You're gonna hear PhD mathematicians talk about ambiguities because of that, and things like that. And I'm not going to step in that. I'm not a mathematician. I'm an engineer. Okay. So that's my level on this stuff. I'm just pointing it out if you ever do run into it. You're going to find out though, and there's another video out there if I ever can find the link again. Gosh, I can't remember the channel. I feel really bad about it, but she did a really good in-depth review of different scientific calculators like I think there were TIs, there might have been Casios in the mix. Some of them, actually, if you even look at their manuals, you'll find out they're programmed for this multiplication by juxtaposition, and their manuals even list it in the order, the hierarchy. They'll even talk about it, and they position it in there like at that step 2.5. The problem is there's scientific calculators out there that don't do it. So, yeah, again, it's really confusing. There's one famous example out there, famous puzzle floating around the internet, the 6 divided by 2 times the quantity 1 plus 2 in parentheses. Now, if you're following order of operations as I've explained it before, and as PEMDAS and BODMAS are supposed to be used, you're going to do the solve inside the parentheses. You're going to get 1 plus 2 is 3. Then you're going to divide 6 divided by 2 is 3. and then finish with your multiplication. 3 times 3 is 9. Now, this multiplication by juxtaposition thing is going to say that after you do the 1 plus 2 equals 3, wow, I got another mistake in here today. This is really some bad editing. I'm going to have to fire my editor, which just happens to be me, okay? 1 plus 2 equals 3. Yeah, okay. Multiplication by juxtaposition would say that after you do the 1 plus 2 equals 3, you solve inside the parentheses, you'd multiply by that implied multiplication before doing the division, even though the division is all the way to the left. So what they're saying is you would take, yeah, you would take 2 times 3 because the 2 was outside the parentheses without a multiplication symbol. So basically your 2 times 3 is 6. Then you do division, which would be 6 divided by 6 is 1. So you can see that if you're following the stricter PEMDAS approach, normal order of operations, you're going to get 9. If you accept this juxtaposition thing, you're going to get 1. So yeah, you'll see a lot of arguments on the internet back and forth, people claiming one or the other. I try not to even get in the middle of that one. So again, PEMDAS doesn't really support that idea by itself. So if you think the answer is 1, you'd have to utilize the multiplication by juxtaposition and say, hey, that's really part of order of operations. So, I really, I guess what it comes down to is I try to separate these acronyms from what order of operations is. I would rather have a discussion about what is order of operations than worry about what PEMDAS or BODMAS or BEDMAS or BIDMAS are. I really don't even like those. I don't like the please excuse my dear Aunt Sally thing. Um, so like, yeah, I said like this whole juxtaposition thing is controversial amongst many, and so it's one of the reasons why a lot of the flame wars heat up on social media, and it's an argument more for those who are familiar with order of operations. Yeah, I've heard the arguments against it. People will say, well, the coefficient, if I go back to this problem we had earlier, the coefficient in front of the 1 plus 2 in parentheses is the 6 divided by 2. Not just the 2, but the 6 divided by 2. That's another argument. Yeah, and I get that, and if you go through and understand your distributive and associative community properties and all that, and you work stuff out, I get it. I understand what that is and how you can make arguments against this, juxtaposition. But it's been used. It's in a lot of scientific journals and things like that. And you may run into it. You may not. I don't know. But like I said, I'm not taking sides on it. I'm just like once again, I'm pointing it out that it's out there. There's a lot better info out there than what I could explain. And I would just say, go and watch a few of those videos, do some research if you want to know more about it. I'm not going to really say any more about it past this. That's all. I'm going to leave it there. Most of the puzzles that I'm going to do, I'm going to put operators in there. I'm going to have multiplication operators. I'm going to have your division operators, your addition, subtraction. I'm more worried about the people who are doing these puzzles and they're assuming that, you throw out order of operations when there's no parentheses. I'm worried about the people who believe multiplication comes before division, that type of thing. I'm worried about those people more than anything. So yeah, I hope this video has been helpful. And if you liked what you see here, consider subscribing. It really will help things out. I do hope at some point to try to get a better microphone, maybe some better cameras, better graphics, things like that, and hopefully share some better information. My goal really here is to try to educate and not humiliate. So, I've been through that in my own past. I can remember in third grade, honestly, a simple addition problem. I've always had kind of anxiety issues, somewhat of an introvert. which may not be the best thing for a YouTube channel to be an introvert. But when I remember being in the third grade, and I can't remember what the problem was, it was something silly like 7 plus 6, and we used to have to go up to the board and write out the answer, write out the problem, write out the answer. Well, I got really nervous and my mind just went blank. And I can remember my teacher, grabbing me by the arm and, with a look of disgust and dragging me downstairs to the second grade classroom. And she, drags me in the room and pauses the class, asks the second grade teacher if she could pause the class. And what does she do? She goes, "Class, can you tell me what 7 plus 6 is?" And the entire class chanted out 13. And you've got to understand, like, I'm I'm in my late 50s right now, and that was in third grade, and I remember that like it was yesterday. I mean, that was complete humiliation. That's something that I don't ever want to do to anybody. And I see the flame wars online and the name calling and, oh, you're a clown, you need to go back to school, that kind of thing. I get it. There's people online who haven't been in school for 60 years. They haven't been in school for 50 years, 40 years. They don't use this stuff every day, right? So what I'm trying to say is like, let's just try to have a civil conversation about some of this stuff and work through it and try to better understand it. I just want people to understand some of these basics and not just, check it off as like woke mathematics or, something ridiculous. This is stuff that it can be applied in real life. And like I said, I'm looking to educate and not humiliate. And I hope this video has been helpful. Again, please like and subscribe if you liked anything you've seen. Feel free to comment. I'm always looking to try to come up with some new ideas or new videos. Sometimes it gets to be the same old thing if I'm repeating similar puzzles and working out similar things. So yeah, have a great day, and I hope this has helped you out.